Hi everyone. Um, Welcome to this presentation. My name is Peter Riley. I am the simulation technical lead on the team at Decision Lab, and I'm here today to present the work that we've done in collaboration with NHS Gloucestershire Hospitals NHS Foundation Trust. And the project is a hospital digital twin for better resourcing and care in dynamic situations. So first off, to give you some background to the project. Um, so as I said, the project is for NHS Gloucestershire Foundation Trust. There are around 8,000 employees, and we were specifically working in close contact with the Trust's analytical team, who have around 20 members. The requirements were to create a digital twin to investigate what-if scenarios at a hospital level, and this would enable supporting optimization of hospital procedures and resources to offer best possible care in dynamic situations. So that's things such as working to modify situations around beds and perhaps the treatment pathways to improve a patient's overall experience in the hospital. And a key challenge is that we were modeling a full journey of the patients through the hospital for both non-elective and elective patients, all the way from arrival to exit. So a non-elective patient is a kind of unplanned arrival at the hospital, such as via the emergency department, whereas an elective patient is generally a planned surgery. And the project was done across two sites, Cheltenham General Hospital and Gloucestershire Royal Hospital. They're both within the same local trust, about a 20 to 30-minute drive apart from each other. Some of the specialties in the model are unique to one of the sites. So that means that in some cases, a patient may be diagnosed or may develop a medical issue that needs to be treated at another site to the one that they're currently at. So again, another challenge was to incorporate the journey time between sites and where that logic fits in place. And as you can see from the site plans, they're very large. It's two large sites with several buildings in each site, and in total, it was been broken down into 75 locations of interest to model. So the logic. So as I mentioned, there are elective patients and non-elective patients. So to first describe an elective patient's pathway, um, they will enter the hospital, and the surgery that was planned has a possibility of being cancelled due to an unavailability of bed spaces. And in which case they simply would leave the model and would have to return on a different day. But if the surgery can go ahead as planned, then there's a certain time spent in surgery, and then afterwards, a kind of aftercare happens in either a specialty ward or the Department of Critical Care for more urgent matters. And then anybody who goes into critical care may then need to recover in a specialty ward. Um, and then after spending time on a specialty ward, the patient would leave the hospital. The non-elective pathway is a little bit more complicated. So on entering the hospital, the standard route for most patients is to go via nurse triage, where the assessment would be made as to the seriousness and the acuity of the issue. Patients get given a score from 1 to 5, and this determines whether they go to a major or minor area. And then following the major or minor area treatment, there's a decision to admit, where it's a decision to decide the next location in the hospital. So whether they are fit to leave or whether they require further treatment in the Department of Critical Care, perhaps a COVID ward, the Acute Medical Unit, AMU, or Same Day Emergency Care, or SDEC. And following any further treatment, they would spend time in a specialty ward, again, which is kind of think of this as a place to kind of recover from any sort of treatment as well, and then would eventually leave the hospital. Um, there's another pathway, which would be going via the Gloucestershire Priority Assessment Unit. When contact has been made with a GP prior to entering the emergency department, so they effectively bypass the emergency department and the triage, and would go straight to a specialty ward. So some of the key concepts in the model is the idea of specialties, which is a word I've already mentioned several times so far. So different medical issues require different types of treatment, and we can group these into specialties, such as things like cardiology, dermatology, orthopedics. And in an ideal situation, each ward would only treat certain specialties. So that's kind of, I guess, based on like staff familiarity with certain kinds of conditions, but it's also probably based on resourcing and kind of proximity to other areas of the hospital. So, like, you would want a cardiology ward to be in close proximity to certain other areas. But there is the potential that if there's not enough space on the preferred specialty ward, a patient can end up occupying a bed in another ward that isn't actually intended to treat their specialty. In this case, they become an outlier, which is the second key concept. So, for example, a cardiology patient. This is kind of a toy example, but a cardiology patient could end up in a dermatology ward, and obviously that is caused by limited capacity of wards. And the reason outliers are um, a, a point of interest and possibly concern is that an outlier, it takes longer in general to treat an outlier because of the lack of available specialism. So to improve overall patient experience, you want to minimize any time spent as an outlier. And the final key concept is queuing. We implemented a customizable priority for queuing for bed spaces. When a bed becomes available, um, uh, there's a ranking of the patients to prioritize. For example, anybody in critical care is the highest priority, and they should be given the bed, for example, over somebody in the same day emergency care. Um, and a key target is to reduce queue times in the hospital for the obvious benefit of improving the overall patient experience. So, onto the model itself. I have a few demonstration videos of the model that we developed. Just to note before these start that the data is a bit, well, kind of only semi-representative, and really just in this case to kind of illustrate the features that we developed. Um, so the first thing I'll talk through is the results page. Um, we can also later see the patient view and the locations view. So on the results page, first off, you can see the emergency department statistics. You can see information on triage nurse utilization, major area utilization, and a key stat of time of whether a patient was treated in under 4 hours. You can also see queue lengths, waiting times, and you can see in that bottom right hand corner queue lengths over time as well. And you'll also see that there's the possibility to toggle between CGH and GRH. You can see that clicking on GRH actually reveals that there's no queues in the walk-in or ambulance for GRH, and all the queuing is actually coming from CGH at the moment. So there's the opportunity to kind of see them at an individual level or combined. There's a second page of emergency department results, which show treatment wait time by triage score, wait time breakdown, and ED resource utilization over time. You can also see some of the other areas that we have got statistics for. So we modeled the theatres where the elective surgeries happen, and also this captures any cancellations and occupancy levels. We also have DCC, which is the Department of Critical Care. it's kind of anticipated that there would be no waiting for DCC because it's so critical, but as kind of a useful statistic to capture and validate that that's happening. In the hospital, we have average percentage occupancy rates, and you can see on the right-hand side, we also have average hospital stay, which is again one of the key performance indicators, and that's split by like standard patient treatment, outlier patient treatment, medically fit patient treatment. We also have finally a queuing results page. The queuing results page, again, as I mentioned before, this is one of the key metrics to see queue lengths in the emergency department, queue lengths out of the emergency department, and for the GPAU and for the specialty bed. And again, just to illustrate, we can toggle between CGH and GRH, the two sites. So I'll just move on now to the patient view. Oh, sorry, this is the location view. The location view, you can select up to 4 locations to display at any one time. So remember, there's 75 different locations across the 2 different sites. So this kind of gives a full list where you can tick any of interest. So I think for this demo, again, it's purely random, just to illustrate the features. But we've gone for 4 sites in CGH. And when you display the results, you get to see this view of bed occupancy and also of queuing at each of the 4 locations. So you get an idea of occupancy and admissions. You can also see with the key on the right-hand side that it also highlights the different classifications of patients. So you can see, for example, in the wards on the right, where there are outliers being treated, and you can also see medically fit. You can click on the ward results, and that allows a bit more detail on the description of the wards as well. And overall, I guess this is kind of a summary of occupancy. And then I'll just move on now to the patient view. So the patient view is about visualizing an individual patient's pathway and journey through the hospital. So there's 2 options and 2 ways this can be utilized. The first way would be to search for a patient by attribute. So clicking on search for patient brings up a filtering system where we can filter by location, specialty, and status. So this example is looking for all outliers in the hospital, and it would allow you to view an individual patient. There's another option to input an ID to view a patient of interest. And both ways, you reveal this patient view that centers on a single individual. So this patient here, we can see by some of the statistics. So they are currently entering the emergency department. You can see, you get a sense of the occupancy level of the emergency department. And you can see that it spent time queuing, and it kind of speeds up the queuing, but it does illustrate that they've so far spent 1 hour and 54 minutes queuing. They then go to the triage area, and you can then see again in the statistics that they get assigned a triage score. And that means that a triage score of 3 would send them to the minor area rather than the major area. So again, there's a wait to be treated in the minor area, and then they then proceed to the treatment. So that's just a kind of snapshot of what would go on in the emergency department, for example. And you can kind of see on the right-hand side that we've got various statistics about the emergency department. The queue sizes, the occupancy, and the utilization of resources such as nurses and trolleys. And there's one final video which shows the kind of snapshot to illustrate how the patient's journey has progressed beyond the emergency department. So in the next video, I've skipped ahead to where they were actually treated in a ward. So you get this location ID to say that this is where they were treated in the Ward 5A chairs tower block. And if I just play it again, you can see that there's a kind of duration that they spend being treated in a bed, which gets kind of sped up for the purposes of the visualization, and you get to kind of see the patient's journey as they leave the hospital. So all of this is to sort of I guess give it an engaging perspective of what it can be like for certain patients going through the hospital, how long they might spend in certain departments, how long they might spend queuing, and you can kind of get that balance of how how long they spent in different areas in different classifications, whether they were an outlier, and if so, how long did they spend as an outlier. Um, so so moving on to just a discussion of, well, why did we use AnyLogic? Um, so so we've got 3 points here. The first one is for the customizable discrete event modeling. It's a very detailed model that I kind of haven't shown the full back end of, but it's essentially it does follow a discrete event format in a kind of lower level way to the logic that I described at the beginning, and we need a lot of customization. So in a delay block, it's not just as simple as saying everybody spends 30 minutes in being treated in the emergency department. We need to be able to do things like base durations on sites, on specialties, and on triage scores. And we also need to be able to have customized queuing that's based on patient classification. So as I mentioned before, for example, a DCC patient from critical care is of higher priority, the highest priority. Again, we need that customization to say that they would be the first to claim a bed when it becomes available. The second point is pedestrian modeling, and how it allows us to visualize the patient's journeys and give a more tangible story about what's happening in the hospital, and to engage stakeholders and interest in the tool. The third point is regarding the navigable and interactive UI. Um, you've seen from what I illustrated, there's a lot of windows, there's a lot of levels to the visualization, and we use AnyLogic to kind of break down and but also organize how these windows should be grouped together. And you've seen we used some interactive components like we used, for example, tick boxes to choose which location should be selected, and we have on-click action, like being able to navigate to certain patients and things like that. So moving on to the benefits and the applications. So it, we output a lot of quite low-level statistics to CSV, and this can be taken on by the NHS analyst team and visualized in any tool that they require. Um, we also, as alongside hourly stats, we also have some summary stats as well. And broadly, we can break these down into three categories: wards and emergency department. So for patients, we specify uh, at, at one level, we even go to the point of specifying every activity that a patient went through. So you see how long they spent in each location and department, and how long they spent queuing, and also time spent as an outlier. For the wards, we output statistics like bed utilization, number of outliers, and for the emergency department, we would output like time to triage and trolley utilization in the major area. Um, so overall uses for the tool, we have we hope it can be used for scenario planning, which would enable lots and lots of different decisions to be made and supported. So reducing outliers, queuing, and length of stay. And we also think it has applications in winter planning, which is often a concern of hospitals in the way that capacity always increases over the winter, and it allows them to stress test their systems and pathways to explore the effects of this increase in demand. We can understand how bed capacity impacts hospital performance. We can investigate how much time patients spend queuing in different areas of the hospital. It would enable planning, for example, to build a new ward. Um, all of the locations are kind of read in from a database. So adding adding a new location is as simple, if I can put it that way, as adding to the database. We don't need to kind of hard code the layout of anything. And answering a question such as, if length of stay was reduced, how does it impact the bed surplus deficit? So the final slide is regarding possible extensions, and how we might develop this tool further in the future. So one idea is for more detailed modeling of staff, such as incorporating shift patterns and maybe linking it up with an optimization engine to allocate the workforce to best utilize them. Another idea would be to build in a scenario comparison window with some charts that allows kind of scenario management, and a bit more usability in terms of what if scenarios. The third point there is on an enhanced UI for input parameters. So we could make a potentially more user-friendly experience to make and generate scenarios. We could incorporate a cost model, um, and analyze the effect on cost of any decisions that we're making, such as increasing members of staff, increasing staff levels, reducing staff levels, building a new ward, that kind of thing. And finally, we could better improve the logic for outlier management, and potentially even if any of these investigations have been done in external tools, in terms of external optimizations, we can at least use the simulation to test out new and improved logic, and see how that changes the KPIs in terms of percentage of outliers. So yeah, thank you everybody for listening. That was the end of the presentation, and I welcome any questions. Um, so I'll just have a look back in the chat. So yes, so the first question was on which type of simulation have you employed? So that was discrete event simulation, and the patients are themselves agents. So it is a sort of hybrid, and we kind of use the fact that a patient has certain characteristics, but yes, these are agents passing through discrete event blocks. We have another question. How long did it take to develop this model and all of the results visualization? So that we've been working on the project. We began at the beginning of April. Sorry, the end of April, and it's now the end of September. So that's 5 months up to this point. Um, and obviously that we weren't working on it all full time, and sometimes we needed like points of review and pauses while we discussed and evaluated and amended things. But yeah, just to give you an idea of the scale, this has been going on for 5 months now. Yes. So is the next question is the approach that you used in creating a digital twin similar to creating a simulation? So we so the digital twin aspect of it is kind of the way it can incorporate frequent data refreshes, and the way it sort of keeps up with a kind of a live twin of what's going on. Um, so I mean, it's an interesting avenue to explore as to how we could maybe take this a step further and deploy it in a way that is maybe more of an automated digital twin, and maybe something where there's a data pipeline to kind of refresh the model at regular intervals. But yeah, so far the use case of the digital twin is by the users kind of frequently refreshing the data and importing it, which, because all of the data has been parameterized to the database, that is possible. The next question, do you account for no-show in the patient's arrival rates and the patient's volume in the waiting area capacity? Um, so so in terms of so the only case of a no-show would be elective, where those patients were planned to enter the hospital. So we essentially model that there isn't actually a kind of area where people wait. I mean, it's an interesting idea. It's potentially an extension to incorporate where is the location that people actually wait before being turned away because of lack of space in the ward. But no, at the moment, those patients don't actually um, physically enter the model. That the kind of the turn away happens before they get the chance to enter. Um, And did you make a feature in which you can see the history of the patient uh, after this has happened, or was it meant to follow an agent during runtime as a debugging tool? Um, so yes, there is a feature where we can output. So when we output the statistics, including at a very low level, as I mentioned, in terms of like patient patient activities. When we get those output CSVs, we can see an ID and we can see what the patient did. So if we're filtering the patient results, and we, for example, we could sort them in terms of which patient has spent the longest time as an outlier. And after seeing the results and seeing the length of time spent as an outlier, you can see that patient's ID, and then you can go back and rerun the model with the same seed, and that's why that's another kind of benefit of being able to specify a patient's ID and run the simulation just for those patients. Um, so average queue length is 0. Is that practical? As I mentioned, this data is kind of only semi-realistic. But an average queue length of 0 should be possible in a scenario where, for example, if there were always a sufficient amount of beds and resources, the patients wouldn't have to spend any time queuing. So although, as I said, this is just kind of semi-realistic in this case, there isn't a very extreme ideal where there wouldn't actually be any queuing. Um, but then obviously there's a balance to find, because that would be very expensive in terms of resources to achieve that. I'm just having a look. Um, so what's the user experience for running what if scenarios, and how can data be ingested or parameters set? Um, the user experience is to load in an Excel input file on the home screen. We've discussed that potentially a future improvement of the model could be to kind of load in the parameters from Excel onto a UI screen to kind of nicely present the data and be a bit easier for the user to kind of walk through all of the different parameters, and therefore be able to kind of almost do a walkthrough. And I think that would help with explainability of what the model is doing. Um, but at the moment, there is still that flexibility that we don't need any logic development to use the tool in any way. We can customize all of the parameters using the Excel file. And I think the end of the questions that I can see in the chat, and I'm aware it's 5 o'clock.
Peter, great. Thanks very much for that presentation. Very interesting, very relevant, very useful for everybody, I think.